I'd like to thank the organizers to invite me for this presentation. And I'm going to show you some results from Brazilian zeolite that we are using here with fertilizer and for animal feed. First of all, let's show something about Brazilian agriculture, and this figure illustrates the high increase of grain yields that we are obtaining, and this line shows that we are not incorporating new land to do this increase in productivity. This productivity is being obtained by increasing the use of the use of fertilizer and technology. Brazil has very poor soils, and they are very acidic and low in fertilizers, in nutrients. So we need lots of fertilizer to obtain this high productivity. Most of our soil here are very poor. We have around 40% of soil, 20% of wood soil, and around 15% of quartz cement. The intensification of Brazilian agriculture requires high amounts of fertilizer, and this became us as the fourth largest consumer of fertilizer in the world. But our production of fertilizer is very low. We need to import 75% of all nitrogen that we use. Around 50% of the phosphorus and 90% of the potash. This became us high dependent on imported fertilizer. Again, this figure illustrates how we are increasing our crop yields, and the blue one shows how we are increasing our fertilizer consumption. But when we calculate our agronomic efficiency, we can see that we are not very efficient. We are decreasing this efficiency. Because many of the nutrients are lost by several mechanisms, like nitrogen that we lost by ammonia volatilization. Our acid soils absorb high amounts of phosphorus, and potassium can be leached due to our low cation capacity, cation exchange capacity. So we are concerned about the use of zeolite with this fertilizer. They are natural nano materials, and probably can increase our nutrient use efficiency. There are about 60 species of natural zeolite, and more than two times of this the synthesized. And these zeolites are aluminum silicates with interesting high three-dimensional structure that possibilities high cation exchange capacity. These natural zeolites can be easily found in the market all around the world. And they have nowadays great potential for use in industry and agriculture. Some examples of the application of this natural zeolites are the treatment of industrial effluent, wastewater purification, treatment of soils with fertilizer as soil conditioner, and the supplementation of animals. The voids in the zeolite texture can be used as a molecular sieve, and it can be used to sort other molecules. The main properties which are great interest for agricultural purposes are this high cation exchange capacity, the high water holding capacity in the free channel, and the high absorption capacity. With this Brazilian sedimentary zeolite, we are trying to improve the efficiency of the nutrient use by increasing the availability of phosphorus from the phosphate rock, the utilization of nitrogen by reducing its loss, and the increasing the use of potassium by reducing the leaching potential. When zeolites are mixed with phosphate rock, can act as a controlled delivery system and can be renewed as a source of nutrients for plants. With zeolites increase the nitrogen use efficiency, the nitrogen uptake, and increase also the dry matter yield, and led reductions of loss by ammonia volatilization. Zeolites also improve the efficiency of water use by increasing the soil water holding capacity and this availability to plants. And also for animal nutrition, we have some results showing that the supplementation of zeolite with urea may regulate the ammonia release in the rumen, allowing continuous synthesis of cellular protein. So the objective of this presentation is characterize and show the results of the Brazilian zeolite rock as a low-release fertilizer, a soil conditioner, and for animal nutrition. Here we can see the three regions, the three principal regions where we can find zeolites in Brazil. Here is the principal occurrence of zeolite, where we take samples, took samples of this mineral to our test. These are some pictures from the collection, of this rock, and where we took this sample. This material was characterized and showed that the principal zeolite species were istubite with high amounts of quartz as contaminated. So we compare this istubite, this Brazilian zeolite, with others well-known zeolite species like the clinoptilolite, that is a Cuban mineral, and this mix of the elandite and clinoptilolite that is a Spanish mineral. All this, the first and the second one minerals are commercial, easily commercial found in the market. Okay, the Brazilian zeolite has a lower superficial area, lower pores, and a lower cation exchange capacity. But our results, this is the ideal formula determined for this mineral, and we had in our sample, in our row sample, zeolite with 470 grams per kilogram of steel bit. This material was crushed and then concentrated to separate this contamination using a dry method to not expand too much this process. And then we obtain a material with 650 grams per kilogram of steel bit. And we classified this material. And we did a test, in a post test, growing 4 crops in rotation using this natural mineral enriched with the nitrogen, phosphorus, and potassium. Our treatments, we test this concentrated zeolite plus potassium, nitrate potassium, zeolite plus this potassium phosphate, zeolite with phosphoric acid and this phosphate rock, and we compare all these treatments with nutrient solution. We tested 4 levels of these mixtures, okay? Here we can see the dry matter production of all the 4 crops that we obtained. This bar here shows our control with nutrient solution, and we can see some interesting things as the zeolite with potassium nitrate as a very good development, and also this zeolite with the phosphate rock. The increasing of phosphorus availability we can show with this and the second figure. Here we have a solid phosphorus source, and here we is the concentration of phosphorus when we begin the experimentation. Here is the second crop, and the first crop, the second crop, the third one. You can see decreasing in the phosphorus availability in the media, okay, using a solute phosphorus source. Now, when we put zeolite plus phosphorus rock and not water-soluble source of phosphorus, what we saw, this was the concentration and the beginning of the experimentation. Here, after the first crop, we can see an increasing of phosphorus availability. And the same we saw at the second crop, showing that zeolite can accelerate this phosphorus solubilization from the rock. We test these products in substrate for citrus rootstock production. We have some interesting results showing that this mineral can be a slow release source of nitrogen, phosphorus, and potassium. We established some curves measuring the dry matter production, leafy area, and always comparing with commercial fertilizers, and we get some really interesting results for the rootstocks production using substrate, organic substrates, and this mineral mix. Okay. Another set of results that we obtained was when we mixed urea and zeolite, trying to improve the nitrogen use efficiency. The first test, we just mixed the urea, the urea granules with the zeolite. We had something like this. And this, the objective of the study was avoid the nitrogen loss from urea, and the ammonia volatilization was captured in chambers for evaluation this volatilization. The experimentation was carried on for 22 days. We made this in pots in a greenhouse experiment, and our results showed that when we increase the zeolite concentration with the urea, we decrease the ammonia volatilization from the pots. This was made in a greenhouse experiment, and then we went to the field. In a vertical pasture, we also carried out an experiment like this. And our results show it also that when we increase the concentration of zeolite in the mixing with urea, we could reduce the ammonia volatilization. In another experimentation, we compare this the mixture of urea and zeolite with other commercial sources of nitrogen, and we also had something very interesting. This line shows the black line shows the volatilization of pure urea. When we put urea with zeolite, this dotted line, we could reduce this volatilization, showing the potential of this mineral to decrease this sort of loss of nitrogen. Zeolite also can be used as a soil conditioner due to its high water retention. So we use the sand soil. We put 3 levels of zeolite. We made some soil water retention. So let's show you the results here. And these are the curves of water availability. Okay, when we put zeolite, our soil can retain more water. The sand soil with the zeolite can increase the water holding capacity, and this can be shown here, where we are showing the water, the availability water capacity, and the black one is the easy availability water. So when we increase the zeolite in the soil, we increase the availability of water for the crops. Another line that we are working with our research team here in Brazil is use the zeolite in animal nutrition, because the dynamics of urea in the rumen is almost the same in the soil. We have hydrolysis of the urea when it's in the rumen, and the ammonium result of this reaction can be lost. So if we have a mineral with the capacity to retain this ammonium, can be increase the performance of this animal. We tried this mineral as a supplement for lambs, and we tried 4 levels of mineral in a dietary for these lambs. Here some of our results. The red line shows the high amount of zeolite in this diet, showing an increase of weight gain of the animals. Comparing the green line is when we do not use zeolite, and the lambs that were fed with the mineral arrived at the adequate weight much more faster than when we do not use the mineral.
Alberto, could we
Another line that we are developing is trying to find another mineral can be used, another aluminosilicate that can have this characteristics.
Could we ask you to wrap up?
Know in the new world. So stibit and bentonite is another mineral. We have some curves showing this absorption of nitrogen, showing that bentonite also can, the blue one also can have this potential for use, okay?
Alberto, this is the chair here. Could I ask you to wrap up in the next 1 or 3 minutes?
Here are my conclusions. Zeolite enriched with nitrogen, phosphorus, and potassium was an adequate, slow-release source of nutrients for plants. Zeolite applied with urea improved the nitrogen use efficiency. Zeolite with phosphorus rock increased the phosphorus availability to plants. This mineral also increased the water rotation and water availability to crops. Zeolite increased ruminant performance. And there are other aluminum silicates with the same potential that should be evaluated. So this is what I want to show you. Thank you for attention.